All right. Hello. Today you're going to be folding these notes on linear and nonlinear functions and getting them into your notebook. You're probably going to want to pause and make sure this gets copied in. I did snip a little bit down the outside of the pages so that my flaps didn't overlap in the middle, but you don't have to do that. So linear functions are going to form a straight line. They have a constant rate of change. That's our slope. X does not have an exponent, and we can rewrite the equations into that slope-intercept form, y equals mx plus b. Nonlinear will not be a straight line. It'll be curved. It does not have a constant rate of change, and x either has an exponent or it's written with a fraction. So we can't rewrite it in slope-intercept form. Again, you're gonna want to pause and make sure that you get this part copied down. Here's some examples. Our graph here, we've got a nice straight line, so we know that it is a linear function. And our table, we're looking at the rate of change. The x is what we can control, so that is often has a constant rate of change, but we're looking at the y. So in this case, our x goes up by 3 each time, and our y goes down by x each time. Our output goes down by x. So it is a constant rate of change, so it is linear. And our equation, y equals 4 times the quantity x minus 1, we can distribute that, and then it becomes y equals 4x minus 4, which is in slope-intercept form, so it is a linear function. Nonlinear, again, pause, copy it down. Take note, I did choose green and pink to help make this more visible to you. It would not be a bad idea if you did that same thing in your notebook to have 2 different colors, keep them separate. So our graph, our nonlinear graph forms a curve right here. It is not a straight line. Our table, our input goes up by 2 each time, but our output, our y, goes up by 9, goes up by 22, goes up by 55. They're varying amounts. It's not constant. It is not a constant rate of change. And in our equation, x is the denominator in a fraction. That means it's not linear. Okay, this bottom part, we're going to go through each one and decide if we think that they are linear or not. So I'm going to start down here. Okay, so our inputs go up by 2 each time. And our outputs go down by 4. Minus 4, minus 4. That is a constant rate, so it is linear. Okay, this graph has a curve, so that is not linear. All right, this table down here, our inputs go up by 3 each time, but our outputs plus 3, plus 5, plus 7, they vary, so this is non-linear. All right, let's look at our equations. Our first equation right here, x has an exponent. That means it's not linear. And our one down here is a double whammy. It is x as the denominator, and it is also x with an exponent. So this one is also non-linear. Exponents. Okay. Our next two, this y equals x plus 5 is already written in slope-intercept form. It is linear. And that second equation, we can do some rearranging. So if we subtract 2x and we move everything kind of over and we divide everything by 3 so that we get our variables all by themselves, we end up with y is equal to negative 2/3 x plus 7/3. So it is in slope-intercept form, so it is linear. All right, let's look at this table. Our inputs go up by 7 each time, and our outputs go down by 5. It is a constant rate, so it is linear. Okay, our graph forms a nice straight line, so it is linear. And this last table, our inputs, x, goes up by 1 each time. Our outputs also go up by 1. So that's a constant rate, so it is linear. All right, please make sure that you are pausing, go back and replay it, watch the whole thing again, make sure that this is all into your notes, glue it into your next available page. We're going to talk more about this tomorrow when I come back, and we're going to have an assignment on it at some point tomorrow. So make sure that we're all caught up on these notes. Have a wonderful day and be excellent for the sub. Thank you very much. See you tomorrow.